Hello and welcome to Computer Science 30S. This is the Liberty Basic Unit, and this is lesson 4, I believe. It's the lesson on subroutines and functions. So after this video, you'll know the difference between a subroutine and a function, and you'll be able to write a custom function as well at the end of this lesson. So subroutines and functions are just like blocks when we did it in Scratch. When you made a block, you were really making a subroutine or a function, just a different name. Subroutines and functions are cousins, and you learned some of this in when we did Scratch. Subroutines do processes but may not return a value, don't usually return a value. The draw a square or draw a shape blocks that we created are like subroutines. They do something, but they don't return a value. They just sort of do a process. So for example, here, this block draw a square. It drew a square, and that's all it did. It didn't return a value, didn't calculate anything. Functions return a single value, similar to the reporter blocks that we created, like this one here, when I asked you to create a block for finding the bigger value between number 1 and number 2. This block determined the bigger number of two different numbers and returned the bigger value. This is a function because it returns something, it calculates something. So as I said, functions in Liberty Basic are like reporter blocks in BYOB or in Scratch 2.0, depending on which one you used. They take values, do something to them, and then return a value. Liberty Basic has many built-in functions. Many of the commands that you are familiar with already are, in fact, functions. Left string, len, cos, basically any command that has a set of brackets after it is called a function. They are the program-defined functions. Today we're going to learn how to create your own. So here is first example. Here's the mainline code. Count the words. Input type of sentence. That should be a question mark there, I think. And we're going to have a variable called sentence string. And print, there are word count, sentence string, words in the sentence. So this right here, word count, this calls the function word count and sends it the variable sentence string. So sentence string was inputted here. Sentence string is then sent to the user-defined function word count, where something happens, and then it's returned a value, and then we're going to print that value right here. And you'll notice that the end of the mainline code is right here, and then after that we have the actual function itself. So the function is called word count, spelled the same way. You'll notice here that the brackets include a string, and we'll get to that in a minute or so, but sentence string goes in place of a string. Again, this is the function definition. It comes after the end statement in the main code. I'm going to set index equal to 1, while word string, comma, bracket, a string of index is not equal to blank. The null string, index equals index plus 1. So basically, it keeps counting. It loops through the variable a string and counts the words that are in the string. Okay, so we'll pull out the first word. We check to see if it's the null one. If it's not, we go to the next word. We keep going word after word after word until we get to the end when it's blank. And then our number of words is equal to index minus 1 because the last word that you pull out was the null string. So it loops through the variable a string, which is called a local variable, and counts the words in the string. So let me explain how this works here. Sentence string is the variable in the mainline code. In the function, that is replaced with the generic variable name a string. And the reason that we do that is because when you are using a function, you want these things to be very generic so that they can be used in multiple mainline codes. We don't want, if you're using a function, we don't want to, you have to go into the function and redefine every variable. It can get very confusing. So we write our functions very simple. We quite often comment them as to what the variables are going to be, but they're very generic, and that way they can be used in multiple places. So sentence string, the value of sentence string is sent to the value of a string. Index is also what we call a local variable. Once this function is returned, index has no value. The mainline code does not know what index is. It was in fact 0. You'll notice here that the name of the function word count is used in the last line of code to return the value to the main code. So you always use the name of the function. It's the last line in the function. And then when it returns back here, that numerical value is sent there as well. Let's talk about some advantages to functions. It allows the programmer to reuse a bit of code in various places. They can create a library of their own functions. You can share libraries with other programmers. You'll likely find various functions online, probably in a Liberty Basic forum. You can probably find user-generated functions. Functions can be called from different parts of the main code, so if you need them multiple times, it cleans up the code, makes it easier to read, makes it easier to program, and above all else, it makes it easier to plan your code, because you know that you can write a function to do that. So you can write generic code instead of having to worry about details. It also allows one person to write the main code and another one to write the functions, or teams of people to work together. The general format of a function looks like this. We have the word function, which is a command, then the function name, and then we have bracket argument 1, argument 2. These are called arguments here. They're the variables that are passed from the main line to the function itself. There's some code here. This is the code that does the function. And then, as I pointed out before, the function name is equal to some value, and then that is returned, and we have the end function to end the function off. Notice the indentation here, not necessary, but it's makes code much cleaner. You can see what's inside individual functions. The variables inside the brackets are called parameters or arguments. I think there's a proper definition for which one and when you call it a parameter and when you call it an argument, but it really makes no difference to me. But I do want to point out again that the last line must be the function name is equal to some value. Arguments can be numerical values or strings. They may not be arrays. We'll talk about arrays in a bit. Once the value is passed, it may be renamed. The variables inside the function cannot see anything but the arguments that were passed, and this refers to the variable's scope. That's the word we use for that. Once the function is ended, the function's local variables have no value, like the variable index in the previous example. This is called passing by value. So we get a copy of the value the argument is passed, but not the original variable. So if you make any changes to that variable in the function, they will not be reflected in the mainline code. There is a way to get around that, and I can show you that right away. This is called passing by reference. If you want the program to send a variable that can be changed, it has to be passed by reference, i.e. by its name, not value. Simply include the command by ref in the function name. So for example here, function word count by ref a string can be now added to the function. So rather than the value of the sentence string being sent to a string, it's the actual variable sentence string that is sent to a string that's sort of linked together, as opposed to just made a copy of. So I'd like you to try adding these changes in blue to the example code. I'll see if I can make that a bit bigger for you. If you're having a hard time seeing that, it'll be available on paper as well. So I'll try to make these changes here just to see what happens. You'll notice that a string will be nothing and sentence string will be exactly what it was before. The variable a string has no value in the main code and nothing happens to sentence string. So you can try that out if you like. Pause the video now. Okay, hopefully that worked for you. Now try adding by ref to the function definition. Just put by ref right in here. Run it again, and now the value of sentence string has changed. Done, because the actual variable sentence string was passed to the function. So we set a string equal to done. So you should be aware of how passing by reference actually works as well. Again, place all functions after the end of your main program. This ensures that the regular program flow does not run into the functions. So here's some practice right here. I'm just going to zoom down a bit here, make it a bit smaller. Very short piece of code that takes a numerical value and rounds it. Here's a number here, 3.2, rounding to 3. So I'd like you to create a function called round that will round it properly. And I'm going to pause here. You should too. Give that a try. And then on the next page, you're going to see the solution. All right, hopefully you gave that a try. Here's the pseudocode for it. Might help you. We're going to get the number using an input. We're going to call the round function, and we're going to print the rounded value. And inside the rounded function, here's how it works. We're going to add 0.5 to the value of the round. Take the int of this, the integer portion of that, and we're going to call this top. We're going to take the integer portion of the original value and call it bottom. So for example here, if the original number was, let's say, 3.2, we're going to add 0.5 to that. We're going to get 3.7. We're going to take the int of this and call this top. So we're going to take the int of this. We're going to get 3. That's going to be the value top. We're going to take the int of the original value, call this bottom. So the original value was 3.2. The integer portion of that is again just 3. We're going to call that bottom. If bottom is equal to top, then the original number should have been rounded down, as it is in this case, down to 3. And the rounded value is both top and bottom. If top is bigger than bottom, then the original value should be rounded up. And so the rounded value is the top value. So for example, here, if my original value was 4.8, when I add 0.5 to that, I'm going to get 5.3. Take the int of that and you get 5. That's our top. The original value, the int of that is 4. That's my bottom. And because top is bigger than bottom, then I should round up. So I get my answer is 5. So a neat little algorithm that will round it for you. If that helps, pause the video now and give that a try on your own. And then the next screen, I believe, will actually show the solution. Okay, so here's that example of how that works. Again, next screen, there's the code for the actual rounding. So input enter the number to be rounded. Rounded number equals round. This is the user-defined function here. Call it round. And we print it rounded. Function round x. Notice that you use a generic variable here. Bottom equals the int of x. Top is equal to the integer portion of x plus 0.5. Top is bigger than bottom, then the function round is equal to top. Otherwise, the round is equal to the bottom. So I've got two settings there. And if, and then I end my function. So if you didn't get that, type that in, give that a whirl, see how that works for you. And you're going to need that on the upcoming hand-in assignment here. So I'd like you to write a piece of code that takes an x and y coordinate and rounds them to the nearest integer. So we're going to round two different things. So you're going to use the round function twice. You're going to round an x coordinate and you're going to round a y coordinate. It then displays them in brackets with a comma in between. Here's a sample. Enter an x coordinate 3.4, enter a y coordinate 4.8. That point is closest to 3, 5. 3 rounds down, the 4.8 rounds up. Use a string function. So you're going to make a function that's called a string function called round and format $, A and B, to return the string quotation bracket 3, 5 bracket. You may call your round function inside your round and format string definition. You should use the built-in function str string at some point to convert a numeric into a string value. So you're going to round it and then you're going to format it with brackets and a comma. This is what the main code should look like. Let me just make that a bit bigger for you. So we're going to input, enter an x coordinate, input, enter a y coordinate, x and y. Rounded string is equal to round and format x, y. Print that rounds to. So that, my friends, is the main code right there. Then we're going to have a function called round and format. You have to write that code. And then down here, function round, this is the code that you just wrote. And it's going to be used twice inside round and format. So you can have a function call another function. Okay, good luck with that assignment, and we'll talk next lesson.